Hello and welcome to my video on the Titius-Bode number series. The Titius and Bode were two astronomers of the 18th century, both with the first name Johann, who came up with a number series that reflected the distances of the orbits of the planets from the Sun and even predicted two orbits. So at the time, at the 18th century, astronomers knew about these planets and Jupiter and Saturn, and they knew the approximate placement of where the distances were from the Sun. So Titius and Bode came up with their rule, which predicted a planet between Mars and Jupiter, which turned out actually to be the orbit of the asteroid belt. The average distance of the asteroids, and even predicted approximately where they would find the planet Uranus when it was discovered. So to understand the Titius-Bode rule, you need to know what an AU is. And an AU is an astronomical unit, which seems to be nothing more or less than the distance of the Earth from the Sun, 93 million miles. I know Titius and Bode would not have used miles, but that's what I'm comfortable with. And so whatever that distance is, since these are all proportions of each other, doesn't matter what measurement, unit of measurement you're using. But this being the astronomical unit seems like a bit of a misnomer. And also being the third planet from the Sun, it's a little bit curious why that's the one. But these other numbers are just the proportion of the astronomical unit. So 35,991,000 is 0.387 times 93 million. So what Titius and Bode did was they said, here's what we're going to do. We're going to start off with the number 0, and then we're going to add a 4. And we're going to divide that by 10, and that's going to give us 0.4. And then we're going to leave that 4 in the formula. The first number, we're going to make that a 3. And then 3 plus 4 is 7 over 10 is 0.7. And then we're going to double that each time. 6, and then 12, 24, 48, etc. And that's going to give us this pattern, and if we look at the pattern, it's okay. It's not a bad pattern. The fact that it was able to do two predictions gives it some weight, and I think is why it's in the history books. Usually when I read about the Titius-Bode rule or Bode's law, it doesn't seem like they give it a lot of weight or consider it very practical, and I think one of my reasons for doing this video is I think it can be a more weighted formula if we adjust some of the numbers. But, in the end, I mean, we're still basically using what Titius and Bode really, the pattern here is the doubling. Doubling is what makes it interesting. Now, if it was something completely arbitrary and they were able to make these predictions, that would be, that would be pretty good too. But the fact that they're double to me is what makes it interesting. So look at the prediction of the asteroid belt. The Titius-Bode was a 2.8. The number of AUs is 2.77. That's a pretty good, close prediction there. Jupiter was 5.2, and the actual number is 5.203, so that's very close. And then the Titius-Bode rule for Saturn is 10, and the AUs are 9.5. That's close enough. And then 19.6, 19.18, that's close. And then we get to Neptune, that's 38.8, and the actual number is 30, so that's not very good. And Pluto, 77 versus 39, that's really off. Now, I don't think that's why they decided to take away Pluto's planetary status, but for our purposes, we're going to keep Pluto as a planet. I don't like the fact that they did away with its planetary status. I think it's Personally, I think it's the deep state, but you never know with those people. So anyway, what I want to do is I want to get rid of some of these arbitrary additions here, like the 4. I think is only there to give us something close to 0.387, and then the 3 raises it to 0.7, and obviously that gets us Venus. So the 3 and the 4 seem kind of, and then doubling 3 to 6. So I'm a little bit forced about this whole part of this number series. So those are the things that I want to get rid of, and we're going to do it in 2 steps. So the first thing I want to do is get rid of the idea of the Earth being the astronomical unit, and we're going to make Mercury, the first planet, be the standard, which seems to make more sense. The other thing it does is, but we eliminate the need for the 4 and the 3 in the rule, and it puts the 0.387 a little bit more into the formula than the 0.4, which is a little bit off. I just think, it's just a slightly more accurate insertion of 0.387 rather than 0.4. That's becoming our unit of standard. You're just a little bit more accurate than you would be, when you're forcing a 0.4 onto a 387. If we look at the numbers now, we get to the Earth is 2.584. Mars is kind of close to 4. The asteroid belt is at 7. Jupiter is at 13.5, and it's not a really very good pattern just yet, but there is something that I want to do further, and I think you'll see that there is a pretty good pattern that goes on. Might be a little bit tough to swallow, but what I want to do here is, instead of taking the distance from the sun of all of the planets, instead of taking this distance, I want to take the orbit of Mercury as being the distance to which we're going to make the measurements. And obviously now it's still an MU is being the standard, but we're going to start Mercury as being at 0 MUs from itself. And admittedly, this is to get a better pattern, but also it's because we're dealing with the orbits and not with the sun. And so I guess it's a little bit arbitrary, but at the same time, I think just doing this measurement instead of the measurement to the sun, it's just a matter of picking and choosing what we want to look at our numbers for. So anyway, so Mercury obviously is at 0. Now if we look at the number of Mercury units each one is, once we get out to Mars, you can see a number that's pretty close to 3. And then the asteroid belt is now at about 6, and Jupiter's at 12, and Saturn is pretty close to 24, 48. And then if we skip Neptune and get to Pluto, you got a number which is pretty close to double Uranus. So starting at Mars being at 3, you've got a pretty good approximate number pattern here. That if you look at the actual proportions, the asteroid belt is less than 2.1 times the orbit of Mars rather. Jupiter is less than 2.1 times the asteroid belt. Saturn is at 1.9, pretty close to double. Uranus 2.05, 3, and Pluto 2.078. That seems to me to be a pretty good, solid pattern going on there. And why did that occur? I don't know exactly. I know that there's something in the news about a possible discovery of negative gravity, or at least it's being hypothesized. I don't know if that would factor into it. I would think that probably over the course of who knows how many millions of orbits around the sun, that you would have a situation where on occasion, as Saturn was at its orbital, and of course everything's very close together here, nothing even close to being proportionate, that it would kind of start approaching Jupiter a little bit, and then as they've started moving away, maybe get pushed out a little bit further, and a little bit of recoil, whatever you want to call it. I don't know any of this. I just know that this pattern here seems pretty significant, which is why I did the video, just because I thought somebody should make a video about it, so I thought that would be me. Hope you've enjoyed it. If you seems important, please feel free to leave comments.